Chapter 14 of Old Time Makers of Medicine. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information, or to volunteer, please visit LibriVox.org. Recording by Adam Marcetich, September 2009, Alexandria, Virginia. Old Time Makers of Medicine by James Joseph. Chapter 14. Basil Valentine, last of the Alchemists, first of the Chemists. Part 1 of 2. Fieri enim potest, ut operator erat et via regia deflicat, sed ut erat natura quando recete tracatur fieri non potest. For it is quite possible that the physician should err and be turned aside from the straight, royal road, but that nature when she is rightly treated should err is quite impossible. This is one of the preliminary maxims of a treatise on medicine written by a physician born not later than the first half of the 15th century, and who may have lived even somewhat earlier. We are so prone to think of the men of that time as utterly dependent on authority, not daring to follow their own observation, suspecting nature, and almost sure to be convinced that only by going counter to her could success in the treatment of disease be obtained, that it is a surprise to most people to find out how completely the attitude of mind, that is supposed to be so typically modern in this regard, was anticipated full 4 centuries ago. There are other expressions of this same great physician and medical writer, Basil Valentine, which serve to show how faithfully he strove with the lights, that he had to work out the treatment of patients, just as we do now, by trying to find out nature's way, so as to imitate her beneficent processes and purposes. It is quite clear that he is but one of many faithful, patient observers and experimenters, true scientists in the best sense of the word, who lived in all the centuries in the Middle Ages. Speculations and experiments with regard to the elixir of life, the philosopher's stone, and the transmutation of metals are presumed to have filled up all the serious interests of the alchemists, supposed to be almost the only scientists of those days. As a matter of fact, however, men were making original observations of profound significance, and these were considered so valuable by their contemporaries that, though printing had not yet been invented, even the immense labor involved in the manifold copying of large folio volumes by the slow hand process did not suffice to deter them from multiplying the writings of these men so numerously that they were preserved in many copies for future generations, until the printing press came to perpetuate them. Of this there is abundant evidence in the preceding pages as regards medicine, and, above all, surgery, while a summary of accomplishments of workers in other departments will be found in Appendix II, Science at the Medieval Universities. At the beginning of the 20th century, with some of the supposed foundations of modern chemistry crumbling to pieces under the influence of the peculiarly active light thrown upon our 19th century chemical theories by the discovery of radium, and our observations on radioactive elements generally, there is a reawakening of interest in some of the old-time chemical observers, whose work used to be laughed at as so unscientific, or, at most, but a caricature of real science, and those whose theory of the transmutation of elements into one another was considered so absurd. It is interesting in the light of this to recall that the idea that the elementary substances were essentially distinct from each other, and that it would be impossible under any circumstances to convert one element into another, belongs entirely to the 19th century. Even so deeply scientific a mind as that of Newton, in the preceding century, could not bring itself to acknowledge the tradition, that came to be accepted subsequent to his time, of the absurdity of metallic transformation. On the contrary, he believed quite formally in transmutation as a basic chemical principle, and declared that it might be expected to occur at any time. He had seen specimens of gold ores in connection with metallic copper, and concluded that this was a manifestation of the natural transformation of one of these yellow metals into the other. With the discovery that radium transforms itself into helium, and that, indeed, all the so-called radioactives of the heavy metals are probably due to a natural transmutation process constantly at work, the ideas of the older chemists cease entirely to be a subject for amusement. The physical chemists of the present day are very ready to admit that the old teaching of the absolute independence of something over 70 elements is no longer tenable, except as a working hypothesis. The doctrine of matter and form, taught for so many centuries by the scholastic philosophers, which proclaimed that all matter is composed of two principles, an underlying material substratum, and a dynamic or informing principle, has now more acknowledged verisimilitude, or lies at least closer to the generally accepted ideas of the most progressive scientists than it has at any time for the last 2 or 3 centuries. Not only the great physicists, but also the great chemists, are speculating along lines that suggest the existence of but one form of matter, modified according to the energies that it possesses under a varying physical and chemical environment. This is, after all, only a restatement in modern times of the teaching of St. Thomas of Aquin in the 13th century. It is not surprising, then, that there should be a reawakening of interest in the lives of some of the men who, dominated by some of the earlier scholastic ideas, by the tradition of the possibility of finding the philosopher's stone, which would transmute the baser metals into the precious metals, devoted themselves with quite as much zeal as any modern chemist to the observation of chemical phenomena. One of the most interesting of these, indeed, he might well be said to be the greatest of the alchemists, is the man whose only name that we know is that which appears on a series of manuscripts written in the High German dialect at the end of the 15th and the beginning of the 16th century. That name is Basil Valentine, and the writer, according to the best historical traditions, was a Benedictine monk. The name Basil Valentine may only have been a pseudonym, for it has been impossible to trace it among the records of the monasteries of the time. That the writer was a monk, however, there seems to be no room for doubt, for his writings give abundant evidence of it, and, besides, in printed form they began to have their vogue at a time when there was little likelihood of their being attributed to a monastic source unless an indubitable tradition connected them with some monastery. This Basil Valentine, to accept the only name we have, did so much for the science of the composition of substances that he eminently deserves the designation that has been given him of the last of the alchemists and the first of the chemists. There is practically a universal recognition of the fact now that he deserves also the title of the founder of pharmaceutical chemistry, not only because of the value of the observations contained in his writings, but also because of the fact that they proved so suggestive to certain scientific geniuses during the century succeeding Valentine's life. Almost more than to have added to the precious heritage of knowledge for mankind, it is a boon for a scientific observer to have awakened the spirit of observation in others, and to be the founder of a new school of thought. This Basil Valentine undoubtedly did, and, in the Renaissance, the incentive from his writings for such men as Paracelsus is easy to appreciate. Besides, his work furnishes evidence that the investigating spirit was abroad just when it is usually supposed not to have been, for the Thuringian monk surely did not do all his investigation alone, but must have owed, as well as given, many a suggestion to his contemporaries. Some 10 years ago, when Sir Michael Foster, professor of physiology in the University of Cambridge, England, was invited to deliver the Lane lectures at the Cooper Medical College in San Francisco, he took for his subject the history of physiology. In the course of his lecture on "The Rise of Chemical Physiology," he began with the name of Basil Valentine, who first attracted men's attention to the many chemical substances around them that might be used in the treatment of disease, and said of him, "He was one of the alchemists, but in addition to his inquiries into the properties of metals and his search for the philosopher's stone, he busied himself with the nature of drugs, vegetable and mineral, and with their action as remedies for disease. He was no anatomist, no physiologist, but rather what nowadays we should call a pharmacologist. He did not care for the problem of the body. All he sought to understand was how the constituents of the soil and of plants might be treated so as to be available for healing the sick, and how they produced their effects. We apparently owe to him the introduction of many chemical substances, for instance of hydrochloric acid, which he prepared from the oil and vitriol of salt, and of many vegetable drugs. And he was apparently the author of certain conceptions which, as we shall see, played an important part in the development of chemistry and of physiology. To him, it seems, we owe the idea of the three elements, as they were and have been called, replacing the old idea of the ancients of the four elements, earth, air, fire, and water. It must be remembered, however, that both in the ancient and the new idea the word element was not intended to mean that which it means to us now, a fundamental unit of matter, but a general quality or property of matter. The three elements of Valentine were 1. Sulfur, or that which is combustible, which is changed or destroyed, or which at all events disappears during burning or combustion. 2. Mercury, that which temporarily disappears during burning or combustion, which is dissociated in the burning from the body burned, but which may be recovered, that is to say, that which is volatile. And 3. Salt, that which is fixed, the residue or ash which remains after burning." It is a little bit hard in our time for most people to understand just how such a development of thoroughly scientific chemical notions, with investigations for their practical application, should have come before the end of the Middle Ages. This difficulty of understanding, however, we are coming to realize in recent years, is entirely due to our ignorance of the period. We have known little or nothing about the science of the Middle Ages because it was hidden away in rare old books, in rather difficult Latin, not easy to get at, and still less easy to understand always, and we have been prone to conclude that since we knew nothing about it, there must have been nothing. Just inasmuch as we have learned something definite about medieval scholars, our admiration has increased. Professor Clifford Allbutt, the Regius Professor of Medicine at the University of Cambridge, in his Harvelian oration, delivered before the Royal College of Physicians in 1900, on Science and Medieval Thought, London, 1901, declared that, "the schoolmen, in digging for treasure, cultivated the field of knowledge even for Galileo and Harvey, for Newton and Darwin." He might have added that they had laid foundations in all our modern sciences, in chemistry quite as well as in astronomy, physiology, and the medical sciences, in mathematics and botany. In chemistry the advances made during the 13th, 14th, and 15th centuries were, perhaps, even more noteworthy than those in any other department of science. Albertus Magnus, who taught at Paris, wrote no less than 16 treatises on chemical subjects, and, notwithstanding the fact that he was a theologian as well as a scientist, and that his printed works fill some 15 folio volumes, he somehow found the time to make many observations for himself, and perform numberless experiments in order to clear up doubts. The larger histories of chemistry accord him his proper place, and hail him as a great founder in chemistry and a pioneer in original investigation. Even St. Thomas of Aquin, much as he was occupied with theology and philosophy, found some time to devote to chemical questions. After all, this is only what might have been expected for the favorite pupil of Albertus Magnus. 3 treatises on chemical subjects from Aquinas' pen have been preserved for us, and it is to him that we are said to owe the use, in the Western world at least, of the word amalgam, which he first employed in describing various chemical methods of metallic combination with mercury that were discovered in the search for the genuine transmutation of metals. Albertus Magnus' other great scientific pupil, Roger Bacon, the English Franciscan friar, followed more closely in the scientific ways of his great master, devoting himself almost entirely to the physical sciences. Altogether he wrote some 18 treatises on chemical subjects. For a long time it was considered that he was the inventor of gunpowder, though this is now known to have been introduced into Europe by the Arabs. Roger Bacon studied gunpowder and various other explosive combinations in considerable detail, and it is for this reason that he obtained the undeserved reputation of being an original discoverer in this line. How well he realized how much might be accomplished by means of the energy stored up in explosives can, perhaps, be best appreciated from the fact that he suggested that boats would go along the rivers and across seas without either sails or oars, and that carriages would go along the streets without horse or manpower. He considered that man would eventually invent a method of harnessing these explosive mixtures and of utilizing their energies for his purposes without danger. It is curiously interesting to find, as we begin the 20th century, and gasoline is so commonly used for the driving of automobiles and motor boats, and is being introduced even into heavier transportation as the most available source of energy for suburban traffic, at least, that this generation should only be fulfilling the idea of the old Franciscan friar of the 13th century, who prophesied that in explosives there was the secret of eventually manageable energy for transportation purposes. Succeeding centuries were not as fruitful in great scientists as the 13th, and yet, in the second half of the 13th, there was a Pope John XXI, who had been a physician and professor of medicine before his election to the papacy, 3 of whose scientific treatises, one on the transmutation of metals, which he considers an impossibility, at least as far as the manufacture of gold and silver was concerned, a treatise on diseases of the eyes, to which good authorities have not hesitated to give lavish praise for its practical value, considering the conditions in which it was written, and, finally, his treatise on the preservation of the health, written when he was himself over 80 years of age, are all considered by good authorities as worthy of the best scientific spirit of the time. During the 14th century, Arnold of Villanova, the inventor of nitric acid, and the 2 Hollanduses kept up the tradition of original investigation in chemistry. Altogether there are some dozen treatises from these 3 men on chemical subjects. The Hollanduses practically did their work in a spirit of thoroughly frank, original investigation. They were more interested in minerals than in any other class of substances, but did not waste much time on the question of transmutation of metals. Professor Thomson, the professor of chemistry at Edinburgh, said in his History of Chemistry, many years ago, that the Hollanduses gave very clear descriptions of their processes of treating minerals in investigating their composition, and these serve to show that their knowledge was by no means entirely theoretical or acquired only from books. It is not surprising, then, to have a great investigating pharmacologist come along some time about the beginning of the 15th century, when, according to the best authorities, Basil Valentine was born. From traditions he seems to have had a rather long life, and his years run nearly parallel with his century. His career is a typical example of the personally obscure and intellectually brilliant lives which the old monks lived. Probably in nothing have recent generations been more deceived in historical matters than in their estimation of the intellectual attainments and accomplishments of the old monks. The more that we know of them, not from second-hand authorities, but from their own books, and from what they accomplished in art and architecture, in agriculture, in science of all kinds, the more do we realize what busy men they were, and appreciate what genius they often brought to the solution of great problems. We have had much negative pseudo-information brought together with the definite purpose of discrediting monasticism, and now that positive information is gradually being accumulated, it is almost a shock to find out how different are the realities of the story of the intellectual life during the Middle Ages from what many writers had pictured them. To those who may be surprised that a man who did great things in medicine should have lived during the 15th century, it may be well to recall the names and a little of the accomplishment of the men of this period who were Basil Valentine's contemporaries, at least in the sense that some portion of their lives and influence was coeval with his. Before the end of this century Columbus had discovered America, and by no happy accident, for many men of his generation did correspondingly great work. Cardinal Nicholas of Cusa had developed mathematics, and applied mathematical ideas to the heavens, so that he could announce the conclusion that the earth was a star, like the other stars, and moved in the heavens as they do. Contemporary with Cusanus was Regiomontanus, who has been proclaimed the father of modern astronomy, and a distinguished mathematician. Toscanelli, the Florentine astronomer, whose years run almost parallel with those of the 15th century, did fine scholarly work, which deeply influenced Columbus and the great navigators of the time. The universities in Italy were attracting students from all over Europe, and such men as Linacre and Dr. Caius went down there from England. Raphael was but a young man at the end of the century, and he had done some noteworthy painting before it closed. Leonardo da Vinci was born just about the middle of the century, and did some marvelous work before the end of that century. Michelangelo was only 25 at the close of the century, but he too did fine work, even at this early age. Among the other great Italian painters of this century are Fra Angelico, Perugino, Raphael's master, Pinturicchio, Signorelli, the pupil of his uncle, Vasari, almost as distinguished, Botticelli, Titian, and very many others, who would have been famous leaders in art in any other but this supremely great period. End of Part 1 of 2.